All right, all you awesome building beasts top. I have two little bits of code over here. I've previously talked to you about PyBricks, and over here on the left-hand side is some PyBricks code, and over here on the right-hand side is some of the code that you guys have written for your current robot runs. I did give a disadvantage of PyBricks last time we were together, and I need to correct that. That's been changed, or I found out about something I didn't realize was in there. So we'll go over that. And you do have some different things that you can think about over the course of me explaining some of this and in days to come. So we've got our face-off coming up with Northern Idaho on the 18th. And then we've got all kinds of stuff that we can do in order to get rid of Then there's all kinds of stuff we can do to get ready for that championship tournament. And right now, I'm hoping not to overwhelm you. Make sure that if you've got any questions, you're writing them down, because I want to make sure that I'm able to clarify whatever I can for you. So I'm going to show you how things look in both your current code, what it could look like in PyBricks, what some of those differences would be, how they would make your robot run different, and then you can use some of these different ideas to help you decide as a team what you want to do, where you want to go with your code, and how you can help possibly speed some things up. That seems to be one of the biggest topics we're talking about lately. How can we get more done with the time that we have? And maybe some of this will help you. So let's go ahead and jump right into it, these side by side of the two different pieces of code. Right here, you can see a lot of the import stuff is the same, but instead of importing from Spike, right, we're importing from PyBricks. That is pretty much the same. One of the advantages of using PyBricks and setting up a new file is it automatically imports all of this stuff for you. So that's really not that big of a deal. You won't even do the import libraries on this one because, like I said, it does it for you. Now, through the rest of this file that we're going to look at, I kept everything labeled exactly the way that you as a team chose to label this. And that's going to help with some of the side-by-side comparisons. Is I use the exact same terminology that you guys did throughout it to help you see how it's going. POW, of course, is the same. We're still going to call in the prime hub. Much of that isn't different. It looks a tiny bit different because we're not doing spike.primehub. We're just calling in the prime hub class. If we were using the Spike Prime application, it would look just like that too. That would essentially be the same. Now, let's go ahead and look at the drive motor. So they're in little different places on both of these files. So right here, right away, I've got the drive settings, and the drive settings are right here that can be set up. This is in the version 2 file of that run 3. So this is the initial drive setting. It's a better one-to-one comparison between the two. Now, with PyBricks, we need to set up the left and right drive first. So here's right drive. It's going to be the same class. We're still calling on motor class. It's port C. Now, we get to choose which is the positive direction based on how the motors are built, how they end up getting placed on the robot. For a drive motor, it is usually going to be clockwise. And for the left drive motor, it is typically going to be counterclockwise. So think about if we're moving our robot in a turn, right is going to be to the positive, left is going to be to the negative as far as our number line looks. And so that motor rotation here is where that's set up. Which direction is a positive forward movement and which direction is going to be a negative or a backwards movement. We have this here where we can reset the angle. And that means Every time we go to use this again, are we telling it to zero out? Or are we telling it that it hasn't made any movements yet? And you can have this true or false. That's something you guys can talk about as you're working on different things, but that is an option that's there as part of the code. Right now, I have both of the drive motors set to true. Here, you can see our left and right. The only thing that gets added to these is just the port that it's on. It doesn't have any of this other information on it. Let's look at motor pair. Here we have a drive base class instead of a motor pair class, but essentially they're doing the same thing. And we'll tell it left motor, and it's this left drive. So we've set up this variable, we've given it a name, and now we're using that variable name to tell us which one is the left motor. It's stuff that you guys have seen before, it's stuff that you've done before. It's now just being used for motor pairs as well. Here's same thing with the right one. We're telling right motor equals right drive. Pretty easy there. Now when we look at your current version, we have some additional settings that come in. So we'll set our stop action, we'll set our default speed, and you'll set your wheel rotation. And we do that by entering in the wheel diameter, multiply it by pi, and in this case, we specify that's in centimeters. Here's a big difference between the two. We are telling it the wheel diameter, but it will figure out the wheel circumference, not us. And it wants those measurements in millimeters only. We're not specifying millimeters, centimeters, inches. We're just giving it to the program in millimeters. So that's what that is, of course, right here. I have a set of calipers, which is how I got this number. I will bring them with me to class and we start doing some different robot stuff. And so you can see how to take some of those different measurements if you've never gotten to use calipers before. One of the other things that's different is we have this axle track as a setting that has to go in with our motor pair, our drive base. And that's the difference between where both wheels touch the floor or touch the surface. This is another place where those calipers come in really handy. We've used our wheels before, and so you can actively see with this light gray line around the wheels where they're touching. I'll take my calipers and I went between the middle of both of those lines in order to get this number, and I can show you exactly how I did that when we're together next. Okay, that pretty much sets up our initialization and our drive motors. Next, we will get into sensors, which I have them here, and I have them labeled exactly the way you did, which you have them up here on lines 11 and 12. One difference I do have is I have eyes or an ultrasonic distance sensor on there. You guys can choose to eventually put one of those on or not. It's one of the things that we will discuss together, and you guys can decide as a team if it's a route that you want to go down. We have another big change when it comes to the attachment motors, and that's here in this line of code. And for this one, you initialize your forklift here, and then you have additional settings for it down here. So let's bump back over to our PyBricks file and take a look. So we're still calling the motor class. It's on port A, and here's where being able to determine that positive or negative direction really helps. So we know, based on your current use of your forklift, that we're having to use negative numbers in order to make your forklift go up and positive numbers to bring it back down. Well, with PyBricks, I have now set it as the positive direction is counterclockwise, so now I can use positive numbers to have my forklift go up and negative numbers to drop it down. It keeps things a lot easier to understand. Your forklift has multiple gears on it, and this is actually the direct line of how they go. Directly attached to the motor is a 36 tooth gear, which connects to another 36 tooth gear and on up through the rest of these. That's how many gears you have on there. That's the number of teeth they have. Having this set gear ratio is really handy for our motors. And we have the same reset angle. Right now, it is currently set to false. Again, that's something you can decide what you want if you get there. Now, we have math in our other code, and we've of course got math in this code. I don't want to think in how many degrees I want to go up. I want to tell the forklift how many centimeters I want it to go up, and that's what I can do right here. Of course, it took some experimenting. So I put my hub on top of your robot, and I made sure that the forklift was set all the way down to the bottom, and it was completely zeroed out. So you know that there's a little mark on your motor, and when those two line up together, it's at true zero, what it will read as true zero. From there, I told it to go up 365 degrees. When I took that first measurement, I read about 0.6. I did the rest of the math, and it didn't quite bring it up a full 1 centimeter. I bumped it up to 0.7, and that seemed to work pretty gosh dang well. You've seen a lot of this math before. We've used it in the PID settings and those drive straight. We've used some different math settings in your previous lift function. So let me bring that up really quick. If we scroll down to your bucket function, here, when we went up 360 degrees, it gave us 3 centimeters, and we divided that by 3, of course, to tell us how much it would go up per 1 centimeter, and we were able to plug that into your lift bucket function. I've put this under the attachment motor section, and then we'll use it later on down in here. Functions are going to look a lot different. Do you necessarily need a function for all of these? No, not really, because for the most part, they're a single line of code. In this case, where the functions come out and help us on the PyBricks side is I want to think in centimeters, not in millimeters. For our drive straight, it wants us to give them those numbers in millimeters. There's 10 millimeters per centimeter. So in my function, I've decided I want to tell it in centimeters, let it multiply it by 10, and do the work for me. So it's still getting the answer in millimeters, but I can think in centimeters. There is no set default stop action. So in each line of code, you can set a different stop action. Where I have this drive as a function, every single time I use it, it will use this exact stop action. Now we're on to probably one of my favorite parts of using motors with PyBricks and something we don't get on Lego Python. There's this wait feature. Right here, you see it wait equal pause. And that's because I have used a variable right here that I want to be able to change later on. But in this line of code, it either says false or true. If the wait is set to true, then it'll completely performing that task before it moves on to the next line of code. If it's set to false, it will run whatever line you've told it to and move on to the line below it at the same time, running 2 different things in tandem. Sometimes I want the drive to wait until it does the next thing. Other times I don't want it to wait and move on. Take the windmill, for example. I want that to be set to true because it needs to go all the way forward before it goes backwards, or else we're not going to get the energy cells off the windmill. But if I want to drive forwards and lift my forklift at the same time, I can set this to false and do both. I'll show you an example later on. Here is my lift bucket. Now you see this great big 2000. What does that mean? Well, that's the speed at which it's running at, but we're working in millimeters per second instead of total percentage of the overall speed. It's definitely a different way to think about it. It's part of the reason that when I was first trying to play with PyBricks, none of my motors would move. But that's because I was in the realm of percentage of power instead of millimeters per second. So that's why you see this big 2000 right here. Then I'm going to tell it the distance I want to go, and I'm going to tell it the distance I want to go in, of course, centimeters. And this is where our math comes in. I will tell it how far I want to go in centimeters, and it'll multiply it by degrees per centimeter we need in order to raise up however many centimeters I want it to go. We have the same then stop action. I like hold, especially when it comes to the bucket. And of course, the same variable here with our weight, like I talked about before. Here, each time we're telling it to reset the lift counted to 0, run for a certain number of degrees, which we're using our math up above in order to be able to think in centimeters instead of thinking of degrees. Then we need a line of code to tell it to stop and a line to tell it to wait. The information I've gotten so far on PyBricks is that it runs a lot better. We don't necessarily need to give it that half a second to settle. But if you guys decide to work with it and we're thinking, hey, this or that is getting thrown off, we can always add that to a function and have that usability there without having to go through and add it in many, many different lines of code. Helps keep everything nice and clean. The turns are also different because we're not using the gyro, and that still holds true. It won't be available until August, maybe September next year, as part of our drive straight or turning functions. Now, because we have given our robot not only the wheel circumference, but how far apart the wheels are, it uses this in calculations on making those turns. We might need to play with some of those numbers up above if our turns are too much, too less, if it's not going far enough, or if it's going too far. Those are all things that can be worked out if this is something that you choose to do, if you choose to write your own version of this code. But that's currently what it looks like. It's a lot like the drive function and the lift bucket function. I can set distance every single time and whether or not I want it to wait. This reset function is probably my favorite part of playing with PyBricks right now. And this is something you don't necessarily have in your current version of code. First, it is going to have the lift run to target. What do I mean by run to target? Or what does the code mean by run to target? Remember, we have a true 0 where everything lines up on our motor? That is exactly where we're telling it to go, that true 0. We're working in speeds of millimeters per second, so this one's still set to 2000 millimeters per second. When it gets to 0, we're going to have it hold those motors, and we're not going to have it wait. Then we're going to run the left drive motor to 0 at 800 millimeters per second. When it gets there, it's going to hold, and it's not going to wait. Finally, we're going to have the right drive motor run to target 0 at 800 millimeters per second. When it gets there, it's going to hold, and now it will wait till all of that is done. Once it's done, it's going to tell both of the drive motors you are reset to 0 and reset your travel distance as though you haven't gone anywhere. Here I have a line of wait code added to it, and I've hashed it out for now because it's not fitting with the rest of the code that I ended up writing. So if I was going to run this, right now I have it set to run that last function we talked about, that reset function. It's going to make sure that the lift is down all the way. Both my drive motors are zeroed out, holding their position and ready to go. Then it's not going to move until that center button is pressed because you're ready to go and it starts out that TV mission. The rest of this right now is going to look very, very similar to what you guys have wrote. I took the exact same numbers on everything that you worked out and plugged them into this code. All of that hard work you did, I used in making a PyBricks version of it. The biggest difference is now we're not seeing speed over here. It's a true or false as to whether I want this line of code to finish or not. In this case, I definitely want it to drive all the way forward and finish the TV before it moves on to the windmill. It makes sense to have it be true for it to wait. And on most of these, you're going to see that. We're doing these different pushes on the windmill. Of course they're true. We have to finish one push before we back up and start another one. Picking up the rechargeable battery. A lot of that's the same. We need to finish this turn before we're driving forward, or we probably won't catch our battery. Now, here we've got another wait. These waits are in milliseconds and not seconds. There's 1,000 milliseconds inside of a second. So in order to get a 2-second wait, we need to write 2,000 milliseconds. I know that part can get a little bit confusing as we're bouncing back and forth between different functions and different versions of the Python language. This wait is here because after that, the robot's going to be picked up, everything's going to reset back to 0 baseline. It's going to wait for everything to be ready and that left button to be pressed. Then it can take the dinosaur home. Here was an initial line of code where the lift was reset back to 0, ground level. But that's okay. We've got it right here where it resets everything back to 0. Right now, why do I have so many resets in it? Well, we've noticed that our robot does a whole lot better when the wheels are frequently getting reset. Is that going to be necessary with PyBricks? I don't know. We haven't run it enough to find out, but it is an option that's really, really easy to put in there. And something that we can potentially do inside your regular Lego code. By no means am I saying you guys have to switch to this. It's just an option, presenting it to you, so you as a team can decide if this is a road that you'd like to go down. Now we have the same, waiting for a button to be pressed, your oil rig, solar farm, and hand. At this point, Sedum grabs the robot. Right now, it's set as a wait for 2 seconds, just like everything else. It resets and then runs the run for finally exiting the system. You don't have to do this in PyBricks. We can run it all as one with the regular Lego Python that you guys have been using. What's the advantage of running it in one single block of code? Well, every time you start a new program, think about it. It takes a while for your robot to think, for that program to actually start. If we never leave the program, it can launch right away after you push that button. It also makes it so you're not taking time jumping back and forth between different programs. So you can keep doing it like you are right now, where we have run 1, run 2, run 3, run 4, and a reset that's all on its own, which, to be fair, you have already added a reset on your run 3 version 3 when it comes to starting things out for the oil rig. Last time we were together, you guys were seeing, especially Bailey, who was running that part of the run. She's the one starting the robot, that it did make a difference if the wheels were reset. See, this one is just resetting the wheels, though. It's not resetting the forklift. And that seems to be a lot more difficult in getting that to work properly with the Lego Spike Prime. It doesn't always necessarily run the way we want it to. We can play with that and see if we can get it to work, but it's run in a breeze, super easy to add to a function in the PyBricks version of MicroPython. So it is something that we can potentially add to this. And this block of code where it resets before Bailey does the oil rig is there. Now, it's set to wait for seconds, but we could always put in a wait for button press instead. These are options that you have regardless of which version of MicroPython you're using. Have it all in one, and then at the same time, still have versions, say something went wrong and the oil rig run didn't start properly. Being able to go to a run 3 and start it from there. Now, I didn't believe that was a possibility when I was first talking to you about PyBricks. But you can write your own menus. You can have menus on PyBricks. And the best part about it is we don't have to stick to their regular old numbers. Here is a version of the menu that I have gotten put together for this run, if I was using it with exactly what you had set up. Most of the import here is the same. Then I tell it what I want my menu options to be. I have an A, 1 through 4, and an R. Initialize the hub. And I want to tell the system to not have a stop button. Usually when you hit that big round button in the center, it stops your program. And at this point, we don't want that button to be used for that. Now we have a while true loop. This is really, really important. So it is reading when a button is pressed and waiting for that button to be released. Then we need to tell it what to do when that happens. So if that center button is pressed, we want to break this loop. That's the button that we are using to select the program that we want to run. But we need to be able to cycle through those different programs. And we tell it we have a menu index and it needs to equal adding one or taking away one of our menu options that we have available that I showed you above. Now we need to reset that stop action. In that case, we're telling it we want that center button to select which program we want to run. And in this part of the code, we are telling it which symbol does what. So I have A or all, and it's going to use our Python code full. We have 1 through 4 run and R for reset. There's no guessing as to which version, which number does what thing. Using letters, smiley faces, all kinds of stuff can be set up as your menu items to help you know which part of what code is doing what thing. I know this can seem really overwhelming, and there's positives and negatives to both. And there's all kinds of stuff that you can do with this as a team. So I'm going to try and break it down one last time in the options that you have and the stuff that you can think about. Firstly, you can keep it exactly like it is, where you are doing your 4 different runs. You have a separate reset mode. All of that's been working. We can also add color sensors and distance sensors into your code to help make some of those variations that are going on with your robot a little bit more consistent. We can take all of the code that you're running and create it into one file using button presses in order to help it start the next block of code, thus making sure you're not having to cycle through different numbers on your hub. We can do all of that with PyBricks instead of Lego Python, taking advantage of being able to run multiple motors at once, cutting off some time. This isn't a decision you have to make right away. And that's one reason I wanted to get this out to you so you can think about it on your own. What are some of your thoughts? What questions do you have? So when we come together as a team for our next longer 4-hour meeting, we can discuss more of the pros and cons. You've actually got to see the code and see how it compares to what you've already written. Now, it's a good possibility that this direct translation won't completely work. And there's some numbers that's going to need to be changed. And that's okay. It's completely up to you. I'm excited to share both of these regardless which road you go down. You're doing an awesome job, team, and we'll talk to you soon.